So what other things could actually affect the operations of the electric motor? Let us see other components of the electric motor and what they do in the electric motor and how they can affect the reliability of the electric motor itself. Okay, so when you look at this is the rotor that we have discussed earlier. Okay, then this is the stator windings that we discussed earlier. Of course, anything that will affect the reliability of this will affect the reliability of the system. But aside these two, if you look, you will see the frame. Okay, and if you look at the frame, you will see some fin-like structures that look like fins on the body of the frame. Okay, we'll come to this later and the importance of it. Then if you also look, you will see that we have a fan that is attached to the non-drive end of the motor. This end is the drive end. Okay, this is the fan attached to the non-drive end, and this is the fan shroud or cover. Are we getting it? So as the rotor is turning, since the fan is attached to one end of the rotor, okay, this generates air, okay, that is blown through this motor frame. So the function of this fin-like structure is to retain the air on the frame as much as possible, so as to enable effective conduction of heat, okay, that will be carried from the winding during operation to the frame of the electric motor, away from the electric motor. So all of this helps to effectively cool the electric motor. So once it is plugged, maybe by dirt covers it up, it will affect the reliability of the electric motor itself. Are we getting it? So we want to maintain it clean at all times, free of dirt, all of this, so that the channel will be open for breeze that will be generated by the fan to go through to effectively cool the electric motor. So other components are the bearings. Okay, so these bearings, as we'll see later, they can also affect the reliability of the electric motor, because this bearing, they are meant to hold this rotor in position, okay, to be in the center line of the stator. Are we getting it? So if peradventure one of them is not properly aligned, maybe because of worn out housing, you'll see that this rotor can rub on the stator, which can affect the integrity of the machine. Okay, so we'll see all of this later and how it can affect the driven load itself. Are we getting it? So the reliability of this seemingly unimportant component is also very, very important to the reliability of the entire electric motor system. So we want to take note of this also. Okay, now we are still on the electric motor system reliability. Remember, we segmented the electric motor system into two. Are we getting it? Remember, we considered the load, that the reliability of the load will also affect the reliability of the electric motor system, as we discussed earlier. Okay, now we want to, for us to ensure the reliability of the system, we ensure the reliability of the electrical parts of the system. Okay, that is the reliability of the electrical system and also the mechanical system. So like we said earlier, as you can see on the right of your screen, that is the electrical system, from the input power through those electrical components, circuit breaker, contactors, the control circuitry, then to your electric motors. Okay, so everything on the power line and on the control circuitry. Okay, the reliability of all of them will affect the reliability of the electric motor system. So we are going to consider that. And then we are also going to consider the reliability of the mechanical part, that is the driving load of the electric motor system. Okay, so here we have a pump, could be a pump, could be a fan, and it could be compressors. Okay, whatever that is driven by the electric motor. Remember, what we needed from the system into our process will be delivered by that attached load to the electric motor system. Okay, so we are going to look at how we can ensure the reliability of this and thus ensure the reliability of the entire system. So, but first, let us look at the electrical system's reliability. So when we say electrical system, remember we are talking of everything from input power to our electric motor through the control circuitry. Okay, so we are going to look at 6 zones, that is the electric motor, 6 fault zones of electric motors. Okay, so we are going to look at the power quality, that is the quality of the electric power that is delivered to this bus, okay, either from your utility, either from the utility in your system, okay, in your facility, or external utility. So we are going to look at that. Okay, then we are also going to look at the insulation fault zone. The insulation fault zone that has to do with the insulation of the windings, either to ground or between phases in the electric motor itself. Are we getting it? So we know that that can affect the reliability or the integrity of the electric motor system, or the electric motor, and thus the electric motor system. So we are going to also look at the rotor fault zone. Remember those components that we outlined earlier, how they can rotor, okay, how they can affect the electric motor system operations. Okay, so we are also going to look at that and what we need to look at when we are testing this fault zone. Then the power circuit itself. But when we say the power circuit, what we are actually talking about is the input feeder line, everything on the feeder line to the electric and the motor winding and to the motor winding. Okay? So all of this forms the power circuit. Feeder line, the components of feeder line, circuit breaker, contactors, all of these they are going to. Then the air gap, which is the space between the rotor when it is coupled, when the electric motor is coupled, the space between the rotor and the stator. So that forms the air gap. Okay? That is the air gap, how it affects the ability of the system. So then the stator itself. In this case, we are going to look at the windings, okay? How it affects the electrical motor systems. Okay.